SpaceX is on the verge of its second attempt to launch the world's most powerful rocket into orbit. Although the initial Starship journey concluded with an unexpected disassembly, we can assert that the upcoming orbital launch will unfold differently. While success remains unguaranteed, SpaceX has implemented over 1,000 changes to both the Starship rocket and the ground-based launch system, ensuring a more thrilling outcome. This next pairing of Starship and the Super Heavy booster represents an almost entirely different rocket from the one observed on April 20th. The upcoming attempt, the 25th build of the Starship upper stage vehicle and the 9th version of the Super Heavy launch booster, incorporates major upgrades. SpaceX's iterative design, approach, and post-April 20th improvements contribute to this significant transformation. A noteworthy alteration is the introduction of hot staging to the Super Heavy booster design, a more dynamic method of separating the two rocket stages after the booster propels the ship above the atmosphere. Originally planning to employ simple inertia for separation, SpaceX opted for hot staging to maintain maximum thrust during the climb to orbital velocity. To execute hot staging, the second stage engines are ignited while the main booster is still operational. Unlike most rockets, there is no main engine cutoff before separation, enabling the force of the upper stage engine to propel the ship away from the booster rapidly. This eliminates any coasting time for the upper stage, transitioning swiftly from full thrust of the booster to full thrust of the upper stage. This is crucial due to first stage separation occurring at a relatively low altitude, where gravity and drag significantly affect the Starship. To facilitate the hot staging maneuver, SpaceX added an additional ring section to the top of the Super Heavy booster. This new ring, with vent holes, safely releases rocket exhaust during the hot stage event. The top dome of the booster's fuel tank has been reinforced to withstand the thrust and heat from the upper stage Raptor engines. Fortunately, the stainless steel material of the Starship is well suited for high heat environments. Attempting a similar maneuver with an aluminum alloy booster, such as the Falcon 9, would be perilous. Regarding the Raptor engines, which were a primary source of failure in the first launch attempt, improvements have been made. Booster 9 features reinforced shielding in the engine bay, addressing issues identified in the April launch. Additionally, the transition from hydraulic engine gimbals to electric motor controls enhances reliability. Booster 9's electric motors replace the hydraulic actuators, aiming to prevent another catastrophic failure. Despite the explosive demise of the first launch, SpaceX's use of the strongest concrete saved the launch pad and tower. The complex orbital launch mount and the colossal robotic launch tower remained intact. To avoid a repeat of the first launch's cratering event, SpaceX installed a new and unique suppression system underneath Stage 0, referred to as the showerhead. Elon Musk mentioned this idea was in progress before the first launch, but time constraints hindered its implementation. Regardless, the hole would have been dug anyway. Following the reconstruction and reinforcement of the launch mount foundation, the showerhead was introduced, comprising two ultra-heavy-duty steel plates with water channels between them. This system creates water jets under high pressure. Unlike typical water deluge systems and flame diverters, the showerhead is more intricate and effective. During engine tests, it produced large clouds of white steam, indicating a departure from the previous static fire tests. These positive outcomes bode well for the next Starship launch attempt. Confirmation of SpaceX's readiness for the upcoming launch comes from the communication between SpaceX and the FAA. The FAA's approval of 63 upgrades and modifications, with 57 currently implemented, signals progress. While 6 modifications apply to future launches, the next Starship on the launch pad will already be an improved version. The FAA concluded its mishap investigation in early September, and on October 31st, the safety review of the property at Starbase and the surrounding area was completed. With the green light from Fish and Wildlife Services confirming no environmental contamination from the showerhead, Starship is cleared for launch. SpaceX is swiftly progressing to get the rocket airborne this month. Although outcomes after engine ignition are unpredictable, the inherent excitement of the event remains certain. The Raptor's engines were a significant point of failure in the initial Starship launch. From the moment SpaceX initiated the booster, 3 Raptor engines failed to ignite properly. As the doomed flight unfolded, another 5 or 6 engines exploded in midair. SpaceX later attributed these failures to fuel tank leaks within the plowing system of the booster's thrust pack, leading to fires in the engine bay. Tracking cameras vividly captured this as the booster approached its final moments before spiraling out of control. SpaceX explained that the fire severed the connection between the engines and the ship's onboard flight computer, resulting in a complete loss of control over the booster. Inadequate shielding between the 33 engines likely caused the engine bay fire. Although this issue was retrofitted to Booster 7 long after its initial construction, Booster 9 was constructed from the ground up with reinforced shielding in the engine bay. It's essential to note that the booster on April 20th was equipped with the first ever full set of Raptor version 2 engines. Considering SpaceX's iterative design principles, the first engines built are expected to be less optimal, as engineers continuously learn and improve. While attention often focuses on the failed engines, an alternative perspective is that, despite a raging inferno and explosions in close proximity, most of the 33 Raptor engines functioned until the vehicle self-destructed. A crucial enhancement to the Raptor engines on Booster 9 is the shift from hydraulic engine gimbals to electric motor controls. Engine gimbals allow the nozzle to swivel, angling the thrust to steer the rocket. 13 engines on the Super Heavy booster have gimbal mechanisms, and Raptors boast more range of motion than other gimbal rocket engines. The hydraulic engine gimbal was a notable failure in the first Starship flight, with the hydraulic pressure system exploding within the first minute after launch. Electric motors, replacing these hydraulic actuators, are simple screw-type motors expected to be more reliable and prevent another descent into self-destruction. In terms of destruction, the explosive demise of the Starship not only jeopardized the entire launch pad and tower, but also created a significant discussion following the first flight attempt. While rocket failures on their first launch are common, the extent of the damage caused by Starship, nearly taking the entire launch infrastructure with it, stands out. Typically, rockets don't explode in midair, but most new rockets fail to reach orbit on their initial test run. However, no previous rocket has left a crater in the ground like Starship. We're talking about approximately 14 million pounds of force applied to a slab of reinforced concrete. While this might seem like an obvious failure, SpaceX deserves full credit for using the strongest concrete available. They didn't expect the slab to survive the launch, but they also didn't anticipate it shattering, allowing the booster's thrust to create a hole and send concrete shards flying in all directions like cannonballs. Fortunately for SpaceX, amidst the chaos on the ground, the only substantial damage was to the concrete slab, a minivan, and several cameras. The highly intricate orbital launch mount and the colossal robotic launch tower remained intact. This proved to be a significant stroke of luck for SpaceX. Starship is not only unlike any other rocket, but the launch infrastructure it demands is also unparalleled. Elon Musk has emphasized that the ground system is more valuable than the rocket itself. While a ship and booster can be rebuilt in weeks, as they are expendable, losing the ground systems would be a worst-case scenario because the launch mount and the tower are integral to Starship. These ground systems are often referred to as Stage 0. In the rocket world, most rockets are either 2-stage or 3-stage, indicating how many times they separate from a thrust section before achieving orbital velocity. Starship is a two-stage rocket because there is only one separation event before orbit: booster as stage 1 and ship as stage 2. Yet it's impossible to initiate the booster without stage 0. This launch mount contains most of the systems responsible for igniting the 33 engines on a typical rocket. While these systems are usually inside the booster, SpaceX, aiming for maximum efficiency and weight savings, designed an outboard system built into the launch mount. Then there's the enormous steel launch tower, the Mechzilla. With its iconic robot chopstick arms, this system is crucial for lifting and stacking the booster, providing an umbilical connection to fuel the upper stage separately from the booster. If all goes well, those chopstick arms will eventually catch rockets in midair. This setup aims to prevent a recurrence of the cratering event from the first launch. SpaceX has implemented an entirely new and unique suppression system beneath Stage 0. Elon Musk mentioned that this concept has been in development long before the inaugural launch, but time constraints prevented its installation. Additionally, they didn't anticipate the rocket creating a hole, but even if it hadn't, the hole would have been necessary. So, it's not an entirely negative outcome. After clearing away the debris of shattered concrete and mangled rebar, SpaceX proceeded to rebuild and reinforce the foundation of their launch mount. Once this process concluded, it was time for what they colloquially called the showerhead. In the Starship realm, practically everything has a whimsical nickname. The showerhead consists of two ultra-heavy-duty steel plates sandwiching channels for water flow, with the top plate perforated to create water jets under high pressure. Unlike a regular shower head that shoots water straight up, these water jets move at specific angles to divert heat and steam away from the rocket's center point. This marks a significant departure from typical water suppression systems and flame diverters used with other rockets. The Starship system is notably more complex. Traditional water suppression involves large hoses pumping water below the rocket, with resulting steam and exhaust gas channeled into a trench away from the launch pad. In SpaceX's engine tests, all 33 booster engines were fired into the showerhead, resulting in a substantial cloud of white steam. This contrasts sharply with older static-fired tests that kicked up dark dust, smoke, and concrete debris. The prevalence of white steam bodes well for the upcoming Starship launch. Confirmation of the second launch's imminent arrival comes from the communication between SpaceX and the FAA, affirming the agency's satisfaction with implemented changes and upgrades. Whenever a flying machine like a rocket deviates from its intended operation, especially in catastrophic failure, the FAA initiates an incident investigation. In this case, it's a routine check to understand what went wrong and ascertain the preventative measures SpaceX is taking. Elon Musk revealed a list of 63 FAA-approved upgrades and modifications for Starship and the launch system. Presently, 57 of these changes are in effect, with 6 applicable to future launches. These are likely design adjustments that can't be retroactively applied to existing rockets. This ensures that the next Starship on the launch pad will already be an enhanced version. In early September, the FAA concluded its mishap investigation, and on October 31st, the agency completed its safety review of the Starbase property. Pending final approval from Fish and Wildlife Services, confirming no environmental contamination from the showerhead, Starship is set for launch. All indications suggest SpaceX is swiftly preparing for liftoff this month. While the outcome after engine ignition remains uncertain, the anticipation of the event guarantees excitement.